Hello, friends. We are podcasting section 3.2 in the AP Stats book. You see before you a set of goals. So after the two classes we're going to spend here, these are the things you want to be able to do. And a lot of this should be pretty familiar. We've already talked about what a regression line is. We've already done it on the calculator. And the line that we've put in on top of those scatter plots that we've made is actually a least squares regression line. And so you already know what that is. Now we just have a proper name for it. And all this stuff about slope and y-intercept is stuff you should remember from Algebra 2. So the only things that we have new to learn here are extrapolation, the coefficient of determination, and the actual nuts and bolts facts about least squares regression line. So moving along, here's a typical problem from page 200 in your book. We have an experiment here to see if activity like fidgeting, non-exercise activity, um, actually uh, helps you lose or gain weight. So you have a set of data here, which we're going to put in the calculator. Let's put it in lists L2 and L3. Once the data is in, we're going to want to make a regression line. And we've already done this, but we'll shoot it again here. And we're going to go stat. We're going to go right out of calculate, and we're going to hit the number 8. Notice there's a linear regression at number 4, but we're going to use the one at number 8. We put in where our x values are, where our y values are, and then we tell the calculator where we want the equation for this line to go. So to find y1, we go vars, right arrow to y-vars, function, y1's the first one, and when I hit enter, I get the equation for this regression line, and if I hit zoom 9, oh, this is going to be wrong. I'm going to get the manatee problem. Hold on. So what we'll do is we'll just review the stat plot as well. Second stat plot, I'm going to go into my first stat plot, and the only thing I need to change here is that my x's are not in L4, they're in L2, and my y's are not in L5, they are in L3. And now, when I hit zoom 9, there are my points, and there is my least squares regression line. And if I've already got the equation for that line, but let's just do that again. There it is. Okay, so we've got a regression line, and we can use this now to make predictions. If I'm given any number of the non-exercise activity calorie figures, I can make a prediction about the fat gain in kilograms. Okay, so that's what we're doing with this line. So there's the line drawn in a little more nicely. So what this shows is if I said how many kilograms of fat gain would you expect given 400 calories of activity, I would say, oh, there's 400, and there's what's predicted. And I can compare that to what I actually got. Okay, so these are points that I actually got, and the green line represents what I would predict from my model. In a little bit, we're going to call this difference between what I got and what's predicted a residual. We'll get to that later. So just to tie it up, this regression line that we just made is a mathematical model. It's an equation just like you had for Algebra 1 and Algebra 2, similar to y equals mx plus b. What you want to be able to do, though, here in AP Stats is interpret what the y-intercept and the slope means. So the slope in this case, looking at this problem, is the change in y over the change in x. So the slope is going to tell me how much fat gain per unit of change in the non-exercise activity calories. All right, and the y-intercept here, the value of y when x is 0, this is the fat gain when there is no change in the non-exercise activity. So just being able to state those sentences in the context of the variables we're talking about is probably the most important part of this activity. All right, I'm going to do another podcast to finish this up.